Hi. In this video we're going to look at actually doing the opposite of when we did the double distribution. So when you did that double distribution, I asked you to try and look for some patterns. So for instance, if you had something like x plus 3 times x plus 4, we would do our double distribution and we would get x squared plus 4x plus 3x plus 12. One thing that everyone noticed pretty quickly, these terms are like terms and they go together, so you get x squared plus 7x plus 12. Now, one thing that I'd like to kind of figure out here is when I check your work, I kind of already know whether you're right or not from looking at the original things. To give you another one, if I was to do x minus 2 times x minus 3, we would do our double distribution and we would get x squared minus 3x minus 2x plus 6, and again these go together, give you x squared minus 5x plus 6. Now I look at this and I recognize, hey, you know what, in the original terms, in the original polynomials, that was a negative 2 and that was a negative 3. And when I multiply those together, I get positive 6. But you know what? If I add these together, I get negative 5. And that's a pretty neat pattern that I think emerged in pretty much every one of these things that we did. If I look here, positive 3 and positive 4 multiply to give you positive 12. Positive 3 and positive 4 add to give you negative 7. So if we continue looking at it like that, if I was to do something like, I don't know, x plus 7 times x minus 4, that would give me x squared minus 4x plus 7x minus 28. These go together and I get x squared plus 3x minus 28. Now the way I've done this before, the patterns that I noticed before, if I take a positive 7 and a negative 4, those multiply to negative 28. But if I add them together, these combine to a positive 3. Okay? If you look back at any of the other problems we've done, that pattern should emerge all the time. And that's actually a very important pattern, because now I'm going to teach you something called the add, multiply, factoring method. Okay, so you've already learned how to factor by GCF. When a GCF exists, you have to factor that way. But if I look at something like x squared plus 7x plus 12, okay, the first thing I'm going to do is look at these three terms and realize there is no GCF. There's nothing in common other than 1. By the way, consider that 1 is in common with everything. So now what I'm going to do is I'm going to ask myself, when I think about the double distribution, there were two numbers that multiplied together to give me that last term, and those same two numbers would combine to give me the middle term. So this is why we call it the factoring by add multiply method. And really, it would be better to say multiply add. We need to start with the product. If you consider why that's important, there are infinitely many things that add to 7. There are very few combinations of integers that multiply to 12. So the way we can do this is we can think about all the factors of positive 12. Okay, what are numbers that multiply to 12? So if I consider that, 12 is 1 times 12, it's 2 times 6, it's 3 times 4. Okay, also consider that positive 12 is negative 1 times negative 12. It's negative 2 times negative 6 and negative 3 times negative 4. So if you think about that factor list, take a look at the combinations of numbers. which set of factors would add to positive 7? Every single one of these multiplies to positive 12, but which set will add to positive 7? Not that, not that, that will. Just check the rest, that will not, that will not, that will not. Which means, okay, I'm going to go back. I told you on Thursday that we're going to try, starting with this, we're going to create these. Which means that when I do the factoring by add-multiply method, or multiply-add method, I'm going to create the two sets of parentheses. The only way to get x squared is x times x. Now, my numbers that I'm going to use that will produce these is positive 3 and positive 4. So I'm going to put a positive 3 and a positive 4. Students always ask if it matters which place these go in. It doesn't, because order doesn't matter when you multiply. Okay? If we wanted to, we could check this. X times x is x squared. X times 4 is 4x. 3 times x is 3x. 4x and 3x is 7x. And then 3 times 4 is 12. This is factoring by the multiply-add method. Okay? Let's try a few others. So if I were to give you x squared plus 14x plus 49. Okay? Again, the first thing I'm going to do is look for a GCF. There isn't a GCF. So now I'm going to look and see, can I create two binomials that multiply to this trinomial? And right now, the way I'm going to see if I can do that, are there two numbers that multiply to 49, and at the same time they need to add to 14? Okay, this one's actually quite simple, I hope, but if I had to, I would think about all the factors of 49. So the factors of 49 would be 7 times 7, 1 times 49, and then the negative versions of that, because that's a positive 49. So negative 7 times negative 7, negative 1 times negative 49, and of course the set that I'm looking for is the set that combines to 14, which is this right here. So this would factor to x plus 7 times x plus 7, keeping in mind that these are equal. Okay? It does get a little bit trickier when we don't have all positives. So if I were to do something like x squared minus 12x plus 36. Okay? Again, no GCF. Please catch on to that. I'm asking for that first. Since there's no GCF, are there two numbers that multiply to 36 but also add to negative 12? Watching out for that sign. Okay? So if I think about my factors of 36, I have 1 times 36, I have 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And then I also have all the negative versions of that. That's a positive 36. So I could have negative 1 times negative 36, negative 2 times negative 18, negative 3 times negative 12, negative 4 times negative 9, and negative 6 times negative 6. Hopefully it's obvious the pair that combine to negative 12 is these, which means that in factored form, this is x minus 6 times x minus 6. Which, if I really felt like being fancy, I could also write as x minus 6 squared. Okie dokie. So, what happens if you have something like c squared minus 5c minus 84? Okay. Look for a GCF. There isn't one. So now I'm going to see, are there things that multiply to negative 84 that at the same time add to negative 5? Notice that I'm paying attention to the negatives. Notice that I'm looking for products first. And this one's a little bit trickier because, got to be honest, I don't know my factors of 84 very well. But if I just go through systematically like I have for all the rest. Okay, so my factors of negative 84. To get a negative product, remember that one number has to be positive and one has to be negative. So I'll start with positive 1 times negative 84. And then 2 times negative 42. I might have to use my calculator and check. 3 does go into this. It's 3 times negative 28. 4 goes into negative 84. It's 4 times negative 21. 5 doesn't go in. 6 goes in. It's 6 times negative 14. And it's 7 times negative 12. Keep in mind, I chose to do this where all the second numbers were negative. I could also have it where all the first numbers are negative. So I could do negative 1 and 84, negative 2 and 42, negative 3 and 28, negative 4 and 21, negative 6 and 14, and negative 7 and positive 12. Now, which pair of those numbers is going to combine to negative 5? Certainly not those. Not those, not those, not those. 6 and negative 14 is 8. Negative 8, that's not it. 7 and negative 12, if I add those together, I am going to get negative 5, which means those are the ones I want. So this would be x plus 7 and x minus 12. Again, it does not matter which order you put those in. You could have chosen to do x minus 12 times x plus 7. The only thing that matters is that the 12 is negative and the 7 is positive. Think about why that is. Okay, because I will definitely ask you that on Tuesday. Let's try 2 more and then we will be done with this. So if I were to do y squared minus 3y minus 40. Why don't you pause the video and see if you can figure this one out, starting with the idea that you need numbers that multiply to negative 40 and add to negative 3. Pause it, see if you can do it, check out the answer. Okay. Numbers that multiply to negative 40 are 1 and negative 40, 2 and negative 20, 3, 4 and negative 10, 5 and negative 8, and that's it. So then all the opposites of that. 5 and 8 are 3 apart, so those are the ones I want. So this would be y for here. Knowing that that's a negative 3, you got to think whether I'd want the 8 or the 5 to be negative. I think it's going to be negative 8 and positive 5. Negative 8 times 5 is negative 40. Negative 8 plus 5 is negative 3. These are equal. Okay. 2 more. So try n squared plus 6n minus 72. Again, pause it. See if you can do this. Come back and see if you get the answer. I know there's no GCF, so it's going to be n times n. The first things that come to mind for 72 are 9 and 8, but that's not going to work. I do know that 12 times 6 is 72. Knowing that that's a negative 72, I know that one of these is going to be positive and one's going to be negative. Since the 6 is positive, I think this is going to be positive 12 and negative 6. And just keep in mind, if I wanted to check it, okay, these things are supposed to be equal, so if I wanted to check it, I would just distribute this out and see if I get the right answer. N times n is n squared. N times negative 6 is negative 6n. 12 times n is 12n. 12 times negative 6 is negative 72. So that's n squared minus 6n plus 12n minus 72. These go together to give me positive 6n. We had it right. Okay? And lastly, if I were to do y squared minus 7xy plus 10x squared, what do you think about that? This one's a little bit trickier, but it does keep the same basic ideas. I need numbers that multiply to this and add to this. I'm going to ask you to do a squared plus a minus 56. Okay, pause it. So I'm looking for numbers that multiply to negative 6, that add. Keep in mind that there is a 1 right here. Okay, so factors of negative 56. Hopefully the first thing that comes to mind is 7 and 8. So I know this is a, and this is a. I know I'm going to use a 7 and an 8. The question is which one's positive and which one's negative. I know I need a negative because the product is negative. Since that's a positive 1, I know that will be the positive and that will be the negative. Okay? So, if you would like, try doing this one right here. See if you can do that one for class. Please be ready to ask any questions, and we will practice this a lot during class. See you later.